Assalamualaikum and hi everyone. In this video, our groups will presenting about application of gravimetric analysis of sulfate in fertilizer. First and foremost, I will start the presentation with the objective of this experiment that we want to achieve. The objective of this experiment is we want to find the proportion of sulfate in a commercial fertilizer. Next, I will continue with the introduction of gravimetric analysis. What is gravimetric analysis? Gravimetric analysis is an analytical technique used for the quantitative determination of an analyte based on the mass of solid. So, we can easily measure the mass of product. For your information, metric analysis is potentially more accurate and precise than volumetric analysis. Besides, these are the types of gravimetric analysis. First, we have precipitation gravimetry. Precipitation gravimetry uses a precipitation reaction to separate one or more parts of a solution by incorporating it into a solid. Next, electrogravimetry is a method used to separate and quantify ions of a substance, which is usually a metal. Last but not least, volatilization gravimetry. Volatilization gravimetry involves separating components of our mixture by heating or chemically decomposing the sample. For this slide, we will go through the application of gravimetric analysis. Firstly, the solvent extraction. Solvent extraction involves separating a compound from a mixture by dissolving it in a suitable solvent. In gravimetric analysis, this technique is used to isolate and quantify a specific component based on its solubility. The second is to determine the inorganic anions and cations. The ions are precipitate as insoluble salts, which are then filtered, dried, and weighed. The third is sodium carbonate, can be determined by reacting it with a known excess of iodine in an acidic medium. The fourth is we want to determine the nickel content of stainless steel. And lastly, the purity of sodium sulfate in the detergents can be determined by precipitating it as barium sulfate and then weighing the precipitate.
Assalamualaikum, my name is Nordina Alisha and today I will discuss about the theory behind gravimetric analysis. Gravimetric analysis is a quantitative method used to determine the mass of a pure compound that is chemically related to the analyte without the need of standardization. Here's a brief overview of how this process works. The analyte in question is converted into an insoluble precipitate. This method is particularly useful for determining the sulfate content in fertilizers. For example, when barium chloride is added to a solution containing sulfate ions, it forms barium sulfate, which is insoluble. The chemical reactions can be represented as follows. Next, we will discuss about the principal steps. First, preparation. We need to prepare the solution containing the analyte and add a precipitating agent to form an insoluble compound. This allows the precipitate to form completely and settle. Then, we need to filter the precipitate from the solution and wash the precipitate to remove the impurities. Then, we have to dry the precipitate to a constant mass and weigh the dried precipitate accurately. For the calculation, we need to calculate the mass of the analyte based on the mass of the precipitate. By following these steps, we can determine the precise amount of a specific compound within the sample, making gravimetric analysis is a valuable tool in both academic and industrial setting. Thank you.
Then we have the methodology. First, we break out a 200 ml beaker. Then we crush a small fertilizer with mortar and pestle. Then we place about 2 grams of powdered fertilizer into the beaker and weigh accurately. Next, we add about 100 ml of distilled water to the beaker with fertilizer and stir to dissolve as much of the fertilizer as possible. And in steps 5, we filter the mixture and collect the filtrate in a clean 200 ml beaker. Then we add about 10 ml of 1.0 mol acid chloride to the filtrate and heat until it is close to boiling. And in step 7, we add 40 ml of 0.2 mol barium chloride, slowly making sure to stay throughout. Then we allow the precipitate to settle. Then using an eyedropper, add a few drops of barium chloride solution. If a cloudy white precipitate forms, add a further 2.0 milliliter of 0.2 barium chloride. Repeat until no precipitate forms. Then in steps 9, we bake a piece of filter paper, then filter the precipitate through the filter paper. And next in steps 11, we wash the precipitate with distilled water, then to the filtrate add a drop of 0.1 mol argentum nitrate. If a cloudy precipitate forms, repeat step 10. Then we remove the filter paper and allow to dry overnight in an oven. And lastly, bake the precipitate and filter paper.
Nama binti Bubakar, and I will be presenting the result of our experiment on the application of gravimetric analysis to determine the sulfate content in fertilizer. Let's start by looking at the table of result we obtained. As you can see, we have recorded various masses at different stages of the process. The mass of the empty 200 ml beakers was recorded as 111.59 grams. The mass of the beaker with finely crushed fertilizer was 113.69 grams. The mass of fertilizer is 2.09 grams. The mass of the filter paper used in the experiment was 1.38 grams. After filtering and drying, the mass of the filter paper with the precipitate was 3.16 grams. Finally, by subtracting the mass of the filter paper from the mass of the dried filter paper with precipitate, we determine the mass of the precipitate to be 1.78 grams. Now, let's go through the calculation for determining the sulfate content in our fertilizer sample using gravimetric analysis. First, we have the chemical reaction involved, which is barium chloride react with sulfate to produce barium sulfate and chlorine gas. Next, we consider the molar mass. The molar mass of sulfate is 96.06 gram per mole. The molar mass of barium sulfate is 233.33 gram per mole. To find the mass of sulfate in the precipitate, we use the gravimetric factor. The gravimetric factor is calculated as follows: molar mass of analyte, which is sulfate, divided by molar mass of precipitate, which is barium sulfate, and then we multiply them with their stoichiometry. By substituting the values, we get 0.411. Using this gravimetric factor, we can determine the percentage of sulfate in the sample. The formula for the percentage of the analyte is weight of precipitate barium sulfate divided with weight of sample fertilizer, multiply them with GF and 100. By substituting the values, we got 35%. Therefore, the sulfate content in the fertilizer is 35%.
So in conclusion, gravimetric analysis includes theory, methodology, results, and calculations. To sum up, gravimetric analysis is highly accurate and precise analytical technique used to determine the amount of a substance in a sample by measuring its weight only if correct steps are applied accordingly to the procedures. So this method is significant in several daily life applications and in obtaining the results of experiments in the laboratory.